There is another huge container having a large chemical reactor vessel was passing through an underpass railway bridge. It got stuck in the bridge. Engineers, all IITs and high class with large experience. Can you remove the bridge? No. This is now stuck. Just 1 inch. It needed 1 more inch to pass the bridge. They couldn't. So they tried their level best. They couldn't do anything. Some suggested jack up the bridge. Bring huge jacks. Let's put. And for jacking up the railway bridge, what do you first have to do? You have to stop the movement of the train. So these things were going on and on and on. And a shepherd nearby, he was just watching. And then he came and said, "What's wrong? What is your problem?" They said, 1 inch. We can't reduce the height of the reactor by 1 inch. We can't extend the bridge by 1 inch. We have to leave immediately. So he said, "I've been watching you all. Why don't you do one thing?" What is the answer he gave them? Solution to the problem? Pallam thodalangarar. No, that is one solution. Pallam thondi adiyilendhu polam. A shepherd, uneducated shepherd, he said, "Sir, tire length பாதி காத்து எடுத்து விடுங்க சார், 3 இன்ச் குறையும். வண்டி அந்த பக்கம் போன அப்புறம் காத்து அடிச்சுட்டு போயிடுங்க சார்." அப்படி ஏன் அவர் சைக்கிளுக்கு அப்படி நிறைய பண்ணி பழக்கம், எக்ஸ்பீரியன்ஸ். ஸோ எக்ஸ்பீரியன்ஸ் டீச்சர்ஸ் யூ வாட் எஜுகேஷன் கான்ட் கிவ் யூ. You have to experience. Life is full of experiences. Learn from your experiences. Whether it's science, economics, or anything. Who is the greatest economist in the world? பேர் கேள்விப்பட்டிருக்கீங்களா? உங்க எல்லாருக்கும் தெரியும். யாரு? யாருமா? எக்கனாமினா என்ன தெரியும் இல்லையா? காசு. எப்படி ஒரு காசு கொடுத்தா அதை எப்படி மேனேஜ் பண்ணணும், அதான் எக்கனாமி. 100 ரூபாய் கொடுத்தா இந்த 100 ரூபாய் வச்சுன்னு என்ன பண்ணணும், அதான் எக்கனாமி. Yeah, your mother is the greatest economist. How do you learn? Higher classes you will have curves, demand curve, supply curve, price differential. Where to learn all this? Just go with your mother to the market, carry her vegetable basket, interact with the vegetable vendor. Then you will know the real economics going on in demand and supply. Your teacher won't be able to explain as much as your vegetable vendor will do. Today you go to the market, tomato is 80 rupees a kg. 2 months down the line, 10 rupees a kg. I think yesterday it was 1.5 kilo 10 rupees in Erode market. How did it happen? You just ask the lady. She said, "Sir, nariya vardu. Truck nariya vardu. Bangalore len nariya vardu." So that is supply side. When the supply increases, price falls. So these are basic economics which you can go to your market along with your mother and learn. Go with them to the bank. You will know how to manage your money, how money can make money, how commerce is conducted in the country, in the world. All these, your books will not teach you alone. Experience. Go with your mother. Just entertainment, watching movies, watching video games will not help you. Go around your life outside, watch it, you will know. So this is basic economics. Suddenly you will find rain, prices of vegetables goes up. Why? What will they blame? What happened because of the rain? Rain is good, na? Rain is good for vegetables, for growing vegetables. But what did this rain do to the vegetable? Supply. It disrupted the supply. So demand is there, growth is there, but they couldn't bring it to the demand center. So that spoiled the supply side. So price went up. Like this, everyday experiences you can learn. Thank you. Now we go to Pune to join gentlemen.
Thank you, sir. Thank you very much. So இப்போ நம்மளுடைய நெக்ஸ்ட் செஷனுக்கு ஐயுகா புனேல இருந்து டாக்டர் சமீர் துர்டே. ஸோ ஹீஸ் அன் அஸ்ட்ரானமி லவர் அப்படின்னு தான் சொல்லணும், சயின்ஸ் கம்யூனிகேட்டர். So as well as he trained as a radio astronomer with a master's in physics, and as well as he was working past about 10 years ago. கிட்டத்தட்ட ஒரு 10 வருடங்களுக்கு மேலாக ஐயூகாவில் வந்துட்டு இவங்க வந்து சயின்ஸ் முக்கியமாக ஆஸ்ட்ரானமி ரிலேட்டடாக நிறைய ப்ரோக்ராம்ஸ் வந்து பப்ளிக் அவுட்ரீச் ப்ரோக்ராம் வந்துட்டு பண்ணிட்டுருக்காரு. இஸ் அ இன்சார்ஜ் ஆஃப் சயின்டிஃபிக் ஆஃபீஸர் and public outreach program in Ayuka, Pune. Sir, thank you very much for your presence for this wonderful occasion.
Pleasure. Namaste to everyone. Hope you're having a good session today.
Sir, audio.
Okay. My side it is clear. Please, can you check?
Yes, sir. Now it's clear. Very clear.
Okay, good. So again, repeat namaste to everyone. Hope you are having a good time at the sessions today. And we look forward to talking more about the Zero Shadow Day, which is a very special event which we are celebrating. Thank you.
Yes, sir. I invite you to give a short lecture about how to measure the diameter and circumference of the Earth using Zero Shadow Day activity, and as well on that Zero Shadow Day. So what is the special for Zero Shadow Day? Please, so here nearly 60 teachers from nearby district in Coimbatore. So it is a program which is organized by Vigyan Prasad, that is a Department of Science and Technology, jointly with Tamil Nadu Science and Technology Center and Galileo Science Club, Ariviyal Palagai. It is Ariviyal Palagai. It's a Tamil popularization and a science popularization movement. So it is initiated by Vigyan Prasad. And also it's a venue is Johnson Institute of Technology. They also supported for past 5 years for popularizing science. So here are 60 teachers from nearby districts and as well as some of the science communicators, and as well as nearly 50 students from nearby schools. So thank you very much, sir, for this join with us for this wonderful occasion. Please, this session to us.
Thank you again, and it's great to be amongst all of you. I'm sorry I could not travel so far for this occasion, but it's a wonderful thing that the organizers have collected such a great range of audiences for us, and we are able to share this special event which we celebrate every year and enjoy every year. And this year we are either making you aware of it, or we are resharing some things which you've already been doing. So I know that there have been some nice sessions today which have already introduced you to the concept of what is called the Zero Shadow Day. So that is something I will also touch upon slightly, because all of you have already tried your hands. But let me share my screen. So I will go into. Okay, just please confirm that you can see the slide.
Yes, sir. Go ahead, please.
Okay, great. So I will definitely, of course, tell you about Zero Shadow Day a little bit, but then I've had other colleagues like TV Venkateshwaran sir, etc. Kanabiran has also showed you some hands-on, I think, about the Zero Shadow. So this is about that, but then using it for a even bigger purpose. Okay, so let's start with asking a question. Okay, this is a question today. If I ask you, you'll all laugh. So is the Earth flat? Is it like this? If I show you a picture like this, how will you react to it? So all of you will probably laugh. Oh, what is this? This is some science fiction kind of a picture, right? How can Earth be like this? We have so many proofs, right? So all of you have seen this kind of a picture, which is also famous as blue marble. Okay, so the picture has been taken by a satellite which we have grown in technology so much that we are able to send cameras on a satellite which is riding on top of a rocket, and we have indigenously developed all these things in India also, and we are able to send these up in space. to look back at ourselves and show us what our world is like. So this is one of the most beautiful, most touching pictures that I see, and every time it fills me with some, great emotion and some feeling of love, also a feeling of concern that this earth needs to be preserved, because that's the only place you look with any telescope. Till now, this is the only place where you have life, right? Which is us, and we need to take care of it. So this beautiful blue marble, now I tell you that it is spherical, and then sometimes you see one side of it where you can see India here and Asia, etc., Africa, and then the other side, almost behind us on this sphere, is this Americas, so continents. Okay, so this is a well-known fact to you, but just think of it if you're, especially if you're a geography teacher. So think of it that how will you prove that this picture is not true and this picture is true? Okay, just think of it sometime. That what is an easy proof that you can give to, let's say, if some children ask us, how will you prove that the earth is round? Okay, and so there are some excellent exercises you can do. I'm not going into all of them, but I'm just making you aware that sometimes we, even in this age, we are taking things for granted, but our responsibility towards the next generation is to make them aware that just don't take everything for granted. If some things are easy to verify. Okay, so it's easy to verify if I drop something, it will fall down. That's everybody knows that. Even a child grows up with that consciousness that things fall, and we should not let them fall. But there are more major things like the earth is round, which we have to take it with a pinch of salt, because our own eyes cannot show us that the earth is flat or round. Right? So if you go out somewhere, you stand on a hillock or something, you'll see the earth as flat, going up to the horizon and finishing there. But still, we say that the earth is like a blue marble. So how is it? You can think of this question. I am not going to give all answers. My presentations usually raise a lot of questions and give only a few answers. So yeah, so this is a question which you can go with, that how can you easily prove that the earth is round? And zero shadow day can play a role. Now again, since we have to talk a little bit about how to measure this earth, so we have to assume that it is round. So let's go ahead with that fact in our minds, that the earth is a sphere. It's a huge, huge, huge sphere. Okay. And from that fact, if you take that as a fact, then it's very, very easy to understand that if you take a small portion of this sphere, okay, if you take only a very minute portion of this sphere, so if this sphere is it's huge and you take only a part of it, then, and you are like a small ant on that little part on a big sphere, then for you that little part will seem flat. Okay, so that is something you can think about. And let's assume that is true. And that's why we, in our local area, we see the earth as flat. But if the earth is not flat, if it's big, then how can we find the circumference of it? Okay, so that's a question which Kanabrian has asked me to talk to you about. And so that is in a way related to an experiment which was done more than 2000 years ago. And I'm not talking about times when there was digital technology and everything, and no satellites, nothing, even electricity was not there. Okay, so in those times, somebody did some exercise, and they could find out that not just that the earth was round, they would actually find out the circumference of the earth. Okay, so that's a very big achievement. If you just think about it, 2000 years ago, that somebody could do it with some simple tools and simple geometry. So the story starts with zero shadow day. Okay, now you all know that why the zero shadow day happens, maybe. So let me just quickly give you the different perspective from what we know today. Okay, so let's say this is the earth. I hope you can see it spinning around the earth, around the sun. Okay, this is a cartoon animation, and the sun is there, the earth is going around it in its orbit. Okay, only the thing that we need to remember here is that it is also spinning around itself. Okay, so it's going around the sun, but all the while it is spinning around itself. So while going around the sun, it's possible to make such beautiful models out of small plastic balls also. If you're a teacher, you just think of how you can make it. Okay, so you can have like the sun as a ball, and then something, a central rod through it, and then around that rod you can put another longer rod at the tip of which the earth is there. Okay, and then that rod can slowly move around the sun. But one thing to remember is that while going around the sun, the earth is going around itself on something we call an axis. Okay, this is that line showing, like, imaginary line which is depicting that axis. But this axis is tilted. Okay, fine, tilted. So tilted with respect to what? Okay, I'm showing it tilted here in this picture. So because it is moving, you have some idea that it is tilted with respect to something which you can see in this picture. In general, when we have any picture, let's say only of the earth, okay, and I say that it is tilted, right? So let's say a picture like this. Okay, I have a stationary picture with the earth here, and the earth's axis is tilted. Then you will ask, tilted with respect to what? Because I can take the earth as a reference, and then it will all be straight. So it is tilted with respect to the sun. Okay, now just let's fix the picture, the animation picture. I've just fixed it at 4 places. You can see the earth, and if the sun had an axis like this, okay, if you take that, then the earth kind of goes in a plane which is perpendicular to that axis. Okay, and that is kind of called the axis of the solar system. Well, it's not so well defined, but then it's still there. And if you don't want to consider that axis, the axis of the sun itself, around which the sun rotates, okay, then you can consider this plane of the earth's motion around the sun. And then if you take a perpendicular to that at any point here, okay, on that axis, on that axial plane, okay, not the on that orbital plane. If you take that orbital plane here, okay, and if you draw perpendicular lines at the periphery, then with that perpendicular line, our Earth's axis is tilted by 23.5 degrees. Okay, and it's not just tilted in some random directions all the time. It is tilted in a particular direction. So you see this direction, okay, is constant. So its tilt is like this, and while it goes around, its tilt remains like this. So it is always tilted towards this side. Okay, this side, this side, this side. It's same. See, you could have said that, okay, when it is here, it would be pointing this direction. When it is here, it could be pointing this direction. So the axis is not going like this every year. Okay, it is like this, and the Earth moves with the axis pointing in one direction, but it is tilted with that perpendicular to the orbital plane. Okay, very important thing to remember, and this is why we get what is called seasons. Okay, so you can take a look at this animation. I hope it runs. Okay, anyway, I can quickly show it to you on in a picture. Okay, so what is happening is this Earth's axis is tilted, and if the sun's rays are coming to us, they are coming directly from the sun, and we can call the middle of this as the kind of the plane of the Earth's orbit. So with respect to that, we take a perpendicular line, and the Earth's axis is tilted, okay, in one direction. So that direction is what we call the north direction. The top, if we can call this the top of the Earth, let's say. So northern hemisphere, the North Pole, okay, is the place where the axis of the Earth kind of meets the ground, and then it keeps going upwards towards one particular direction. And thankfully, at this point of time, we have a star in that direction, which we call the Dhruva Tara, or the North Star, the pole star. Okay, so therefore it is easy to determine or to verify that the Earth's axis is always pointing towards the north, because anytime during the year, the North Star is at a fixed position in the sky. Okay, the rest of the stars seem to be moving around that North Star. Okay, very important observation sometimes in these days we are getting the information directly, and then we are not thinking about the observation's importance. So if somebody tells you, okay, that is the North Star, and the north direction of the Earth's axis is pointing towards it, you just we take that directly. But we can also think of it like this. Just reverse the logic, that if I see some star pointing in one direction, I see one star, and it is always at the same point in the sky. It's suppose there's some tree or house or something, it is always on top of that, and the other stars seem to be moving in the sky. Then what does this mean? Okay, so we can also think it like that, because at some point of time somebody thought this question, and then they came to the answer that Earth may have an axis, right? So that's something we can also start thinking about. So think a little differently, think the opposite way. Instead of just accepting the answer, think of what questions could be made out of that answer. It is also maybe a good habit for the students, so that they increase their brain power a little bit. So I'm telling you that the Earth's axis is pointing towards this particular direction, and this direction remains fixed throughout the year, and that's why we have the North Star in the north direction all the time, all through the year. Okay. Now, also because of this, a very important thing happens on Earth, and which is very important to our life. And just now I heard the other expert talking about weather and seasons, and how unseasonable rains are happening, etc. But these seasons, if they didn't change, right? So if you had summer at some point of the Earth all the time, and winter at the other point all the time, right? It would not be good for us. But thankfully, it changes over the year, so we can have the cycle of weather, cycle of water, and everything, and therefore we can have a great life here with good food and everything. So this is very important. You see, if this is in the north direction is here, okay, and the Earth's axis is pointing in this direction, okay. So in December, therefore, the north pole of the Earth itself is pointing slightly away from the sun, okay. And since the sun's plane is like this here, then we draw a perpendicular line, as I said here. So then the north pole is actually always, okay, because the Earth will be turning at this point like this. So the north pole will be constantly in the dark. Okay, so that's for the north pole in the winter times, in December, what we call winter. For you, if you see for the people here in the southern pole, south pole, it is constantly in the sun, right? It's always getting light because the Earth is turning here on that date, right? So it will get 24 hours light. So for them, it's summer for the southern hemisphere people, right? And the southern hemisphere people are getting more direct sunlight, so they are having their summer, and it's very indirect sunlight in the northern hemisphere. So we call it winter. Okay. Now this changes when 6 months later, the north pole is north of the axis is still in this direction. So more sunlight is coming towards the north hemisphere compared to the southern hemisphere. And this is something we have either learned in geography or just taught. But this is very important to realize that if the Earth's axis was not tilted, we would not have the seasons. Okay, so the seasons are not caused because the Earth moves close to the sun in the summertime and moves away from the sun in the winter time. No, that does not happen. Okay, and in fact, this is called the perihelion. Okay, and this is called the aphelion, and they do not happen in December, which has the longest day. It happens in January, and this happens in July. So there is no relation to the Earth's orbit being close to the sun or far from the sun. It's more related to the axial tilt of the Earth. Okay, and that causes the Earth to be in this, let's say in our winters, it is tilted away from the sun. The north hemisphere is tilted away from the sun. In the summers, it is tilted towards the sun. During the equinoxes, the whole face of the Earth, okay, from North Pole to South Pole, here also from North Pole to South Pole, because of this particular inclination, can get light throughout. Okay, all of it from North Pole to South Pole gets some light, right? So and the equator has a direct light on that day. So these are the inclinations, and because of that, as I said, once the Earth is tilted towards the sun, and in the winter it is tilted away from the sun for us. Okay, and now this causes various things. The day length is defined by this. Okay, Of course, day length, by day length, I don't mean whether there are 24 hours in a day. What I mean is the time of the light that you are seeing. Okay. So, and also the angle with which the sun rays fall on the earth also change. Okay. So you can see in this particular picture on summer solstice, you can see that some rays of the sun are falling on the sun, on the earth, but it is not the equator. This is not the equator. This is the Tropic of Cancer. Okay. So the sun rays are perpendicular on Tropic of Cancer, but at equator, they are falling at an angle of 66.5 degrees. And at the Tropic of Capricorn, they are falling at around 43 degrees. Okay. If you go even further north, there also there is a change because the earth is curved, right? Again, you can kind of prove that the earth is curved if you have these numbers. So here, the sun rays are falling at 46.5, and at the poles, you're getting 23.5 degrees. Here at the Antarctic Circle, it's already 0 degrees. No sun is falling beyond this. So beyond this, any point towards till the South Pole, any latitude will not get any sun. Okay. So let's go ahead with this. This is the summer solstice, which is in June. What happens slightly earlier? Okay. And this is something we'll, let's say, talk about. So let's go back now in history. Long time back in history. And there was a person in history called Eratosthenes. Okay. Eratosthenes was actually, let me see, I may have this picture. Yeah, just a second. Sorry, I should have combined these two quickly. So this is the person Eratosthenes, lived before the Christian era started, and he was one of the first people. Actually, he was a geographer. He loved maps and loved the earth and knowing about its surface. And so he was the first person to even use the word geography, which means making a map of the earth or writing about the earth, taking notes about the earth, studying the earth. Okay. So when he lived on the earth, okay, he did this amazing feat. He measured the size of the earth and came very close to finding its circumference. So at his time, this was the map of the earth known to people. Okay, so of course, Americas were not discovered because we had not dared to go beyond them. There were some places known like Britannia, some part of Europe. These were ruled by various other people, various other dynasties. This was Africa also was not completely known. So this area around the Nile was very well known. Also the countries like Libya, the Greece, which is close to the Mediterranean Sea. So all places close to the seas and water bodies were very well known. Okay. Then we had the Persia here. Then people would climb through the mountains and get to India. So these things were the known lands. Okay. And there was a prevalent theory that the earth is flat. But okay, Eratosthenes had other ideas. So what he said, he lived here in Egypt. Okay, what was at that time Alexandria, the capital of the Greek Empire, was here in Egypt, and the big river Nile was a very important place. Okay, so Alexandria was where Eratosthenes lived. Okay, and he had, in fact, access to the world's biggest library, one of the biggest libraries in the world at that time, the Library of Alexandria. And he had another friend who lived close to a place called Aswan, or what is called Sain nowadays. Okay, it's a place lower down in latitude. Okay, close to where the Aswan Dam is right now. So he had a friend there. Okay, and they used to chat, and they came to know that the shadow of the earth, shadow of any object, okay, with the sun's light falling on it, it keeps changing over a day. That's something you should definitely try out, finding out. Okay, but then it's not just the length which varies over the day, but if you fix the day and the time, and if you look at the shadow at two different places on the earth, okay, the shadow is different. Okay. This is very surprising thing that he talked about. Okay, and it was a revelation to him that the shadows could be different at different places on the earth. Okay, and he also knew that on a particular day, that if you have his friend had a well near his house. Again, this is an actual picture of the well. And on a particular day, which was June 21st, this person, when he looked inside the well, the walls of the well did not cast any shadow. Okay. Or if you just look at it in a simple way, if he had a pole near his house, that pole would not have a shadow at mid-noon. Okay, on June 21st. This was a friend who lived in Sain. I just told you about Sain. So you can quickly check. It's just a minute. Yeah. So Sain is this place here. And now you can be a little more focused, and you can see that Sain is actually, the latitudes are also written here. So 25, 23 and a half, close to 23 and a half. Okay. And Eratosthenes lived somewhere beyond 30, 32 or something. So he knew that at 32 degrees on that day, there was a shadow of the pole, but his friend did not have any shadow. Okay. So, so that's something he realized. So there was a small shadow at his place, but at his friend's place, things had no shadow. That's where the zero shadow day relation comes in. Okay. And again, you know these experiments which you have to do. So if you have a place where you know there is a zero shadow day, then you can use this method, which is called the Eratosthenes method, to find the circumference of the earth, just like he had done earlier. Okay. But there was a slight thing I will tell you. The story is more interesting than just finding something by geometry. So, so this is the thought process that he went through. He thought of two similar, let's say, sticks. One is put in Alexandria, and one is put in Sain or any other place where there is a zero shadow on particular day. Okay. Now, this, if you extend these lines, okay, the lines perpendicular into the ground and to the center of the earth, both of these sticks, then they will form this angle between each other. Okay. Let's call it theta. Okay. Now, these two lines are at an angle, but now if you look at the sun's rays, here the sun's rays are perpendicular on the stick, so there is no shadow, zero shadow. But on this stick, they are not completely perpendicular to the top, so this stick will cast a shadow. Okay, and by geometry, you'll notice that this shadow's edge, okay, is parallel to this line, which is joining the no shadow stick to the center of the earth. So if you take the angle between the shadow's edge and the stick here, by law of parallel lines, you can have this theta equal to this theta. Now, this theta is difficult to measure. How will you measure such a large angle inside the center of the earth? But just by simple geometry, you definitely can measure this theta and then relate it to this theta. So they are equal. Okay. Now look at the lovely mathematics. So if you know this theta, then you know here the theta is 0 because there is no shadow. And the angle between the shadow and the stick here is theta. Okay. This theta is also a representative of the chord. Okay. You know, this chord is a part of a circle. And so this, let's say this chord is S. Okay. Okay. On the, so this chord is S, right? And if you know this chord length, okay, then it's possible to find the Earth's circumference. How? Now I'll tell you. See, this theta and this S have some correspondence, right? So therefore, if you know the theta, then you know this theta is part of a complete 360. Okay. 360 is the circle and theta is the part of the circle. And now you can know the fraction of it. So for Alexandria and Sain, for Eratosthenes and his friend, the angle for them was about 7 degrees, which is 1/50th of 360 degrees. So you divide 7 degrees by 360, you get 1/50th. Okay. Now you just apply that logic that if this is 7 degrees, okay, and which is 1/50th of 360, then let this S be something, some distance. Then this will also be 1/50th of the whole circumference of the earth. Does that make sense? I hope it does. So it's just connecting various things. So if you know theta, okay, you know what fraction this S is of the whole of the Earth's circumference. Okay, so that's simple geometry. You can write it down on a paper and you can propose that, okay, now I will find the Earth's circumference because I know the theta, and because of that I know this S. And no, I don't know the S yet. That's the catch. So that's where the contacts which Eratosthenes had at his time came in handy. So the thing is that he did not know this distance between Alexandria and his friend's place. So he actually, the story goes that he talked to the king and he got a few army fellows to walk from Alexandria to Syene in a straight line. Okay. So the thing is that army people, when they march, they usually have a step length, and you will see how nicely, even on like Republic Day parade, etc. They all match their steps nicely, and each step will be of equal length. So they were told to march, not just walk like they're going for a morning walk, but they actually marched from Alexandria to Syene, and then they counted the number of steps they had taken. Then there's another averaging thing. So then they counted the step length of each person, and then they multiplied, and they came to a rough number of 800 kilometers. Okay. So now we know the S is around 800 kilometers, and that is 1/50th of the whole circumference. You multiply that and you come to the circumference, which is 50 times of 800 kilometers, which is 40,000 kilometers. And that's a great feat, because the actual value is, on an average, is close to 40,000, only 40,075 kilometers. Okay, so you can see how close he came. The error is so less than 1% there. Okay, so that's amazing that with simple geometry and using the zero shadow day, which his friend was having, he never had it. His friend was having it. He could actually use it to find the circumference of the Earth. Now, that's something which I also suggest that you do these days, because now you have things like maps, atlases. Okay, you have Google Maps also, right? Or you can just ask Google or some other search engine that what is the distance between two places. So what you can do is you can definitely try out the things which must have been told to you. You take a rod and you measure the shadows, etc. And particularly come to know when you will be having the zero shadow day. Okay, and anybody can do it. Even school children can do it. As you see, this is the terrace of Ayuka where I work, and school children, they come and regularly do these experiments with us. They learn themselves and they do it. Okay, and on zero shadow day, they are especially very happy because, you know, vertical objects do not have a shadow on the moon, on the noon. Sorry. Just confused. So at noon they have no shadow, and they also work with us. They do this lovely graph plotting where over time, okay, they take the distance, the shadow length, and then they plot and they find out the minimum shadow. On zero shadow day, this length becomes 0. Okay, lovely experience. But now this can also be extended. So on zero shadow day, you can find out when your zero shadow day is, and on that day you do an exercise where you find the time exactly at which zero shadow happens. Okay, and exactly at that time you tell another person at another latitude, hopefully at your own longitude. Okay, that's kind of important. Otherwise you can just choose 12 noon or the time at which your local noon is happening, and you tell your friend that you find out the shadow length of the stick. Okay, so if you find out the shadow length of the stick, then I'm sure, you know, you can again do the geometry. So you consider this to be a right angle triangle, see this to be right angle here. So you know the shadow length. This is the shadow length, and you know the stick length. Therefore, you can definitely find the hypotenuse. Correct? So you do that, and that will give you the angle here. Okay, or you don't even need to find the hypotenuse. You can directly use the laws of right angle triangle to find the angle here, and that angle, you know, is a fraction of 360 degree. Then you find the distance between that person's place and your place, but along the longitude. That's one important point to remember. You have to find it along the longitude. So you take your own latitude, their latitude, and find the distance between them along the longitude. And that will give you a way to find out the complete circumference of the Earth, and you can verify it yourself. So that's the best thing, that without having to even resort to looking at some book for that value or looking at Google, you can yourself calculate it. Okay, isn't it wonderful that you can do such an activity all by yourself and by using this method called Eratosthenes method? So I'm sure you'll be doing this, and of course there are many other things, many other great activities which you can do with the zero shadow day. So I will stop here, and I've tried to briefly describe to you that how zero shadow day can be useful in finding our own circumference. Other days also you can do this. I'm not saying it's not possible, because see, on other days you may not have zero shadow day at your place, but both the places, both you and your friends will have an angle. Okay, so you just find the difference between these two angles. Zero shadow day is especially interesting because you have zero shadow day and you are finding the circumference. But you can do this on other days also, where if you have a stick outside, your friend has a stick outside at the same time, same local time, then you can easily basically compare those two angles. The difference between them has to be considered instead of that theta between 0 and theta. Okay, so yeah, just find out some day, collaborate with some friends along various longitudes, yeah, and then call them up saying, okay, I'm finding this angle, you tell me your angle, and then just go ahead and find the circumference, confirm it. And this will also help you confirm that the Earth is round, correct? Because I find it very difficult actually, that if you consider all the methods which are suggested to easily prove that the Earth is round, not all of them are foolproof. And that's why for a long time people were believing that the Earth is not round. Okay, despite having known the circumference, they were finding it difficult to believe. So I think I hope that your zero shadow day experience is good, and you will also put it to other uses like finding your own circumference of the Earth and verifying it with others. Thank you very much.
Thank you, sir. Thank you very much. If any questions? Yes, question. Yes, sir.
Please relate to me. I'm happy to answer.
Sir, I am Tanav, sir. Another way you can find the Earth is round, not flat, is the gravitational force of the Earth and the space will not let the Earth to be flat, but the gravity inside the Earth will immediately make the Earth into a sphere, even though by circumstances it became flat, which is not possible.
Okay, I can take that as an answer. In case you understand the law of gravity, then I can give you full points. But the actual, the numerical form of the law of gravity also was very hard for Newton to derive, and it came about 1,600 years later than Eratosthenes, 1,800 years. If you can you quickly tell me what is the law which tells us the force of gravity? I always ask questions. I give very little answers, but I always ask other questions.
Sir, I can't understand.
Do you know what is the law, the form of the law, the mathematical form of the law of gravitation?
P is equal to mv, sir.
I don't think so.
Sorry, that's momentum, sir.
Yeah. It's F equal to or G equal to something M1.
F is equal to mg, sir. F is equal to mg.
Okay, so you go ahead and think about it, and that is actually correct what you're saying. But then that law has to be known properly. If not known, then I will not give you points for your answer.
Thank you,
good
sir.
Try. You go ahead and find it out. Very good.
Thank you very much for your nice session, sir.
My pleasure. Any other questions are welcome, if you have time, of course.
So this is Vasudevan from Veba Erode. It was a pleasure talking to you all. Your address to the children and the teaching committee here in Coimbatore was very enlightening. The children, of course, have a lot of questions. throughout the day, and tomorrow we'll try to answer some of them to the best of our ability. Thanks
Sure.
for sparing your time. We wish we could have interacted personally, but due to COVID norms and all, we had to take it as an online class. A couple of us are here to help the children with their hands-on activity. It was a pleasure talking to you. Thank you very much, sir.
Pleasure also. Yes. And keep
Thank
asking
you. Thank
these
you very much,
questions.
sir,
That's
for your
my-
wonderful time, because you are busy, I know. But last 2-3 days before I contact you, because you agreed this time for 1 to 1:30.
No, don't. Let's not get into formalities. I'm always here to give time for any thing which is useful for teachers and students. Just
Yes.
remember me. I will be there if I can be. So it was a pleasure, and I leave you with this simple thing that you get your answers. The students' aim in life is to get answers and more answers, but that will come only if you ask questions. So keep asking questions and get those answers. If you don't get them now, you understand that you will be probably able to understand that answer in 2 years, 3 years, but go to that level. That's how a student should progress, not only through reading books and believing what others say, but by asking your own questions and finding your own answers. Thank you very much for giving me this chance, and all the best in your efforts.
Thank you, sir. Thank you very much. So now it's a time for lunch break. It's the time is 1:40. So lunch முடிச்சிட்டு 2:28க்கு எல்லாரும் ஹால்குள்ள வந்துருங்க. 2:28. That is the time. Yes. எல்லாத்துக்கும் லஞ்ச் சேம் பிளேஸ். காலையில பிரேக்ஃபாஸ்ட் போனவங்க தெரிஞ்சிருக்கும், இல்ல போகாதவங்க கைட் பண்ணுவாங்க, வாலண்டியர்ஸ் முன்னாடி இருக்காங்க. ஸோ நீங்க அவங்க கூட போகலாம்.